Welcome everyone to another show and share. It is May 4th, and tonight we have air, water, rain, and paper. I'm not sure how paper is going to fare in this, considering air, water, rain, maybe it's, but we will see how it fares. So I want to ask everyone that if you have a project you would like to show, please do so by sending an email with some pictures to sas@knoxmakers.org. That's show and share, sas@knoxmakers.org. So can we start it off with Chase? And I think Chase is going to show us something with air.
Hello. All right. Yeah, I'm really excited to be starting this off because it can only get better from here. This is my very first electronics project, and I was sort of operating under the mantra of if it looks stupid and it works, it's not stupid. Well, it works about half the time, so it's only about half stupid, but you know, it works. So let's go ahead and get started. So first slide is, so this is the inside of a ceiling fan remote control. And this is a project from a few months ago, so I'm a little fuzzy on the details, but I'll do my best to remember. But I was going down the rabbit hole of smart home automation, and we have the ceiling fan in our living room. And I thought, okay, well, that might be a cool thing to automate and, you know, write schedules for and do all sorts of stuff. You know, I mean, why not? You know,
Yeah.
So I started looking into, well, you know, how do you control? I use Home Assistant. I'm running that on a Raspberry Pi 4, and it's this great little open source smart home controller software. I mean, it's got tons and tons of plugins. It's a really neat project. So I've got that running, and I'm trying to figure out, okay, how can I get that thing to talk to this ceiling fan? And I sort of looked at different options. There are pieces of hardware out there that that you can get that for a given frequency will emit you can read in the codes that, you know, different remotes or pieces of hardware, whatever, emit to control whatever it is they control, but it'll only work for that one frequency. And this fan is a weird frequency. I found lots of pre-built things where you could just, you know, put in what you want it to say and it would spit it out. There are lots of those things out there, but none of them that could communicate with the ceiling fan. So I forget the frequency. I think this is like 370 megahertz or something like that. It's something that I couldn't find one of those pre-built emitters for. So what this is, what you're looking at, is the guts of a spare ceiling fan remote, the bottom of it, and I should have included a picture, but if you just imagine on the opposite side of where all those wires are connected are 4 little buttons, and those are the buttons that you use to control it. So since I couldn't find something that I could manually like read the codes into and send them back out, I just took this remote and I figured, okay, I'll try to emulate button presses. So what this is these are wires from an Ethernet cable, and they are soldered to, you know, I don't know the correct terminology, right? The contacts, the opposite side of the buttons, and so I'm able to output a signal through these wires, and, you know, make the remote think that this button has been pressed. So if you're going to go to the next slide, it's a glamour shot of my horrible soldering skills, but I'm sure, lots of things wrong with this, but so far it's held up and it's, not really being moved around or anything. It's just in a box sitting still somewhere. So uh, it works, right? I probably could have left a little more insulation on the wires, but um, I actually ended up, if you go to the next slide, throwing this whole thing back into the remote. And there's a little slot there where you would hang it up on a wall, but it opens up into sort of the inside of it. So I was able to put this thing back together with minimal damage. I didn't really, I mean, the hardest part was just kind of shoving the wires through there. If I wanted to, I could just take this whole thing apart and I would just have a plain old remote again, which is nice, right? In case this thing didn't work out. I'd just end up with a spare remote, no harm done. But so, right, I've got the remote. I have a way of emitting the, I have a way of communicating to the fan. I need to figure out how to get this remote to talk to Home Assistant. So I think the next slide, this is this is what I came up with. So I've got a little 4-channel relay board, and that thing on the left that you can't see super well, I don't have the, I think, header pins, right? I don't have those soldered in yet, but yeah, that's a Node, a D1 Mini. It's a little ESP 8266 based development board. So that can communicate with Home Assistant. There's a little plugin where you don't have to write a whole lot of code. So the way it goes is I tell Home Assistant I want the Node the Node D1 Mini, that little development board. I want it to do something, and then it can toggle one of those pins, and those pins go over to that relay board that we're looking at right now, and that basically simulates a button press so that it shorts the contacts. I don't know if that's the word. It closes the circuit between two wires, and that fools the remote into thinking that somebody's pushed a button. So the next slide, I think, is, yeah, there it is. You can see the development board a little better. So here it is. It's living in a pencil box because that's what I had. But that's the whole thing. And like I said, it works about half the time. I've kind of put this one on the shelf for the time being. I think the D1 Mini is rebooting or going into like a deep sleep or something like that every so often. So I'll get this click from the relay board every, I don't know, hour or two whenever it happens. So it's a real quick thing. It, no harm done, but it's just more annoying than anything. So, but when it works great. So the next slide is getting it set up and talking to Home Assistant. And so this is that plugin, ESP Home is the name of it. And really all you have to do, there's no, I don't really code much at all, but I can edit a YAML file. And that's really all you have to do with ESP Home. So what this is doing is saying, okay, I have a switch. You kind of tell it what language to speak. Platform is GPIO. You can name it and do some other fancy stuff. But basically what this is saying is anytime one of these pins switches high, wait 1 second and then switch it back off. And there are 4 of them, one for each of the 4 buttons on the remote. So then the next slide is actually setting up the card in Home Assistant. So for each of those switches, it creates an entity in Home Assistant, and entities you can, are sort of like the things, the objects that Home Assistant controls, right? So I'm just pulling each of those switches into Home Assistant, making a card, making it nice and pretty. And then the last slide is the actual controller. So I can go in here, I can toggle these little buttons. It'll wait 1 second and then flip back off. And if all has gone well, then the ceiling fan does the same thing. And yeah, I mean, it works. The only problem I've had with it is the random power cycling. I'm, it's on the shelf for the time being, so I'm not really entirely sure what's going on with it. But it works. The only trouble is the relay board clicks once an hour or so. So it's not the worst thing, but yeah, just sort of a mild annoyance, nothing terrible. But this is my first time, doing any sort of soldering, electronics, coding in heavy quotation marks, that sort of thing. But I'm really pleased with how it turned out, and I'm sure there was probably a solution that would have taken about 10 minutes. Just swap something out in the ceiling fan instead of going through all this, but that's the fun of it. So but yeah, I love Home Assistant. It's such a great project. There are so many plugins for it, so many extensions. You can do tons and tons of stuff with it. And so I figured, well, okay, let's control my ceiling fan, and that's that's how it went. So there we go. That's my first electronics project.
I think you did really well. Speaking from someone who tried to teach themselves how to solder, and Isaac, bless his heart, did compliment me on the unusual technique I used. It seems that it works better if you put the pins through the board and solder on the bottom of the board instead of trying to solder right on the pins.
Oh yeah. Yeah, this is my first time soldering header pins, and it was an experience. It took some practice, but nothing shorted, as far as I can tell. Everything worked out, but there's a learning curve, at least for me.
Yeah, well, at least in the process, as Isaac is saying, the out-of-the-box solutions, and you showed the process, and along the way, you picked up more.
Yeah.
All right. Thank you so much, Chase.
Yeah, of course. Thank you.
Up next, we have water with Jeremy.
Hey. Hi, my name is Jeremy Roberts. I started with Knox Makers a couple of weeks ago. I'm a software engineer with your local global corporation here in Knoxville. So I've been chuckling the whole time that I was watching Chase's presentation, because my presentation is going to be quite similar. If you can go ahead, go to the first slide. So about 2 years ago, I decided that I wanted to get into aquariums, and really what I wanted to do was saltwater. But after I started doing research, I realized that it was really complicated and expensive. But one of the things that really fascinated me was the ability for some of the tools out there, some of the gadgets. There's lots and lots of gadgets out there. Is some of the tools that allowed you to do monitoring, to turn things on and off, to automate water changes, to do be able to do leak detection and have our access to all of that stuff away from home. Of course, I'm not away from home anymore, but I'm still interested in all that. So one of the things that if you'll go to the next slide, this is probably the thing that kind of kicked this whole thing off. And if you're look down at the bottom and have a bit of sticker shock, I won't be surprised. Because basically what you have here up in the top middle is that relay board that Chase was showing, except there's 8 of them hooked up to mains power. On the right, you've got what's essentially a Raspberry Pi. You've got a little box over there, and then in the front, you've got a couple dosing pumps. I figure there's probably about $200 worth of parts there. If you can go to the next slide. So in case you couldn't tell, what I do not have a saltwater tank, but I do hope to one day. So this presentation is really kind of talking about the different things that I've done. One particular project, but one of the things that I picked up is a little bit of woodworking. So I built that relatively inexpensive frame that turned into a slightly more expensive frame. If you can go to the next slide. So this is basically this is the project that I built, the little purple box up there. What we have here is 2 jugs. I don't. One has fresh water, one has drain water. You got a couple little peristaltic pumps up there that push water in as a auto top off, pull water out as for drain. By the way, aged aquarium water makes a fantastic plant watering. My plants have never looked better. See if you'll go to the next slide. So the things that you're seeing here, the purple and the gray, those are both 3D printed. I printed those. I CAD'd them and printed them. But the gray braided strip has has a couple sensor wires, and the water tube. If you go to the next slide, I think it's the next slide. Yeah. So the little clips, those are again things that I designed and 3D printed. They're down at the bottom. You've got a water level sensor, just a simple float valve. Oh yes, my son tells me that I have to be sure to let you guys know that he helped with the frame, with the box, the stand. And we did a great job. So the clips clip onto the metal rod, and it just kind of keep everything in place, and also use gravity to keep the float down where it's supposed to be. So if you'll go to the next one. I remember what's what. Okay, so this is the box. The purple box is I designed it, 3D printed. We'll get to that in a second. I've got a lot of pictures, so we're just going to kind of go through them. If you'll see the entrance of the braided cable goes into the box. I've got those zip tied in place to keep the tubes in place so that I can kind of gently move things around without it falling apart. If you can go to the next. So had to learn some 3D. So this took a while, probably longer than I care to admit, and probably a lot longer than somebody who knows what they're doing would have taken. But all the little squirrely bits on there are mounts and places to put the electronics. If you'll go to the next. So these are parts that so I'm from software, so I try to iterate fast and fail fast, and I usually do. So these are just little parts that I printed out so that I could have a 20-minute print instead of a 4-hour print to see if something fit. So the whole time I'm trying to make sure that the screw holes are lining up and that the diameters are fitting, and that I can fit things in and they're not falling out, that kind of thing. So I think there's like 17 or 18 of those there. And then once I actually did print both the lid and the box itself, I only had to print it one time, as opposed to going through, it shortened the iteration time down quite a bit. If you can go to the next slide. This is inside the box. In the top right, you got a barrel jack. I can never remember which one, if it's male or female, but a barrel jack. Then on the left, you've got a buck converter. So I feed it 12 volts, but the Wemos D1 Mini running ESP home is running off of I think it's 5 volts. So you've got power coming in, power to the ESP8266, and power from the buck, and then you can see that the motors are kind of mounted in there. You can go to the next slide. This is the driver that I'm using. So it's a PWM. There's some other words in there. MOS, it might be a FET. Anyway, so it allows me to do PWM pulse width modulation for on 5 volts, and it flex it on the 12 volt side so that I can power those. In reality, in retrospect, I didn't need it. I have never run it at anything other than 100%, but I thought I was going to, so there it is. Let's see if you'll go to the next slide. I think that's just another shot of the buck. Let's go to the next. Yeah, so this is a nice action shot of the zip tie. Let's see if you'll go next. This is a not press fit. It's a heat. It's a threaded. I don't know the name for it. I used a soldering iron to melt that thing in there, and then it is complete overkill for the project, but nothing is putting enough stress on there to warrant a brass thread. But again, here we are.
We are makers.
That's right. I wanted to, so I did.
Yeah.
So if you'll see, you can see that the again, another gratuitous use of a zip tie in the kind of the right middle, and that's holding that braided piece in place so that my wires don't get yanked out. You'll go next. So this is the original prototype for the board, and all of this is way over engineered. This is the original prototype. I didn't really know what I was doing, so I'm using screw terminals everywhere. So if you'll go next, this was neat and tidy, but it took me a long time to put together. So one of the other skills that I got to play with and try out and learn is laying out the schematic. So this is the schematic that I used. If you'll go, and this was done in Easy EDA, I think, which great tool, not to plug them, but did a great job. If you'll go next, it made it really easy to create a design a PCB, and I'm sure there are much better PCBs, but I might ever made one. So if you'll go next, and I made a PCB, so I was pretty excited about that. Everything fit. It was the right size. I was pleasantly surprised. So you saw that mounted in there earlier. If you go next. And yay, ESP Home. I wish I had a clip of Paul Hibbert's Home Assistant. So this is the same thing that Chase was showing. I love ESP Home. It makes things incredibly versatile. It's super duper useful. I don't think I would do anything IoT home related that wasn't running on an ESP8266 or an ESP32. It's just really, really powerful. And I can't say enough good things about it. If you'll go next. So this is just the schedule that I've got in Home Assistant that runs the auto water change. I'm paranoid, so the pump won't run for more than 60 seconds. So if you'll see down at the bottom, down the repeat, it basically every minute and a half it runs for 60 seconds, and it also gives the auto top off a chance to put water back in. You know, I guess I didn't actually tell you guys what this thing does. But basically, if the water's low, it tops it up, and I set this up so that at night when I'm asleep, it pulls about a quart and a half of water out every day. So because I'm lazy and I don't like doing repetitive tasks, so I'll go to great lengths to automate it. I mean, great lengths. So like I said, this is a project that's been about 2 years in the making. Can you go to the next slide? I think it's done. Oh yeah. So that's all the slides. A bonus. That's an aquarium, the 12-inch cube that I finished over the weekend. This is 2 years in the making, and
Wow.
yeah, well, because I was kind of like before I had never soldered anything. I was in the same boat as Chase, never soldered anything. So I ended up setting up Home Assistant. I ended up getting a fair number of tools. I bought, lots and lots of little things that have failed and things that have worked. I've got, lights now on timers in the house and those kinds of things. So there was lots and lots of branches off of this. It's just that was kind of the culmination. But now that all of that stuff is set up, I wanted to do a little light for another little aquarium that, and it took me like 30 minutes, which that, you know, that's to me is pretty incredible. So yeah, it's been an absolutely fun, fantastic project, and yeah, that's it.
Yeah, quite the journey with a lot of, like you said, a variety between the 3D printing and the electronics, woodworking. Got a lot of different skills.
Yeah, it was I never thought that I would end up going quite that far. I knew starting out that I was going to probably do some woodworking, and I knew I wanted to do some electronics, but I didn't anticipate like getting into the 3D modeling and 3D printing. So that's been a lot of fun. I've really enjoyed that.
All right. Well, thank you so much. And we can definitely tell you are one of us. Over engineering is welcome here. We make it work well.
Absolutely. Oh, thank you.
Thank you. So Tim, are you going to bring some rain on this presentation?
There we go. So I'm experimenting here a little bit, so give me a moment to get things. I'm going to try to do this live from the front yard. If I can get all my little camera things working right on the phone here out in the yard. Let's see.
And I am
That comes through. Can you guys see what I'm up to there? There we go.
So anyone who wants closer view, you can open up the, enlarge his screen, his camera.
Hey. All right, so is that working? The sound's okay?
Oh, here's some birds.
Yeah, so I'm here in my front yard. About roughly 2 years ago, we kind of made a decision here at the house to do things a lot more sustainably. So we kind of looked at, where our food is sourced from, how much energy we're using. We got, a little herd of Priuses or Prii, if you will, and put the truck out for occasional use. And one of the things we decided to do was to start growing a lot of our own food. So my kids have moved out. The front yard that they played in is now sort of a little small farm, if you will. And we grow, I think, probably somewhere between 1/4 and 1/3 of the food that we consume here in the front yard. So one of the things along with that is, there are a lot of routine kind of jobs to do out here. We grow tomatoes and peas and beans, cucumbers, celery, ginger. We've got a fig tree, blackberry, raspberry canes. All that takes, maintenance and such, and so it's all just been planted. So in a few months here, all these cages will be just covered with green, and it'll just be a dense jungle out here. But one of those tasks that we have to keep up with is watering all this. And of course, everybody's always hearing about pushing rain barrels. So I looked into a solution for that. And I realized that on the front of my house, I have a perfect opportunity for capturing rain here. It's about 40% of my roof comes off that top section, comes across this bottom one. and I took one of the gutters out that was right here. The downspout I took out here, and right now I have only one downspout that comes down over here on this corner. So that downspout feeds my set of rain barrels that I have out here. And these rain barrels for that roof there, about 500 square feet on the roof, about 1/10 of an inch will fill one of these barrels. And so they've just been, with all this recent rain, they've been just overflowing.
Oh, yeah.
Got a little diverter that's here that brings the water down. Either I dump it to the ground if they're overflowing or if they're in the winter. But most of the time I'm capturing the water in the rain barrels, and then they're just daisy chained one to the other at the top there with spigots across the bottom. So I can either fill up the watering cans, or what I've recently just kind of got finished going through is I can attach a hose here, run this hose across the driveway, and I take that back out to run it into essentially what are soaker hoses in the yard. And this is all gravity powered. There's no pumps or anything. So my soaker hoses are actually just old discarded hoses that half of which are donated, half of which I just picked up on the side of the road. So I'll screw the other end of that hose, the supply hose, into this soaker hose that's here. And then along the way on these hoses, I've tried a number of things to do this, but they're cut periodically. And I've done this with a drill, I've done it with a nail, I've used a punch, and one of the fastest things was just to get dirty scissors and come along, nip it every 8 inches, every foot or so, and they just it works kind of a low pressure gravity system. Cup, and I'll dump about a half a barrel or a barrel into each of these rows. For a 1-inch rainstorm on that roof, I can fill those barrels, that half of an inch, and save it up to back on the garden later whenever we need, it's a dry spell and all that. I can answer questions.
So, Tim, we've lost your audio.
Oh, no.
There, you came back. Uh-oh. Are you back with us now? You're on mute. He's just teasing us with that audio.
Okay, can you hear me?
I can hear you, yes.
All right, we're trying to get the camera back on. I think I walked too far out of Wi-Fi range.
That's what someone else was maybe thinking. We also hear a little bit of an echo. Like
Oh, yeah, that could be.
from the beginning.
Well, okay. So I guess I've finished showing. If you can hear me all right, we can let the audio or let the video pass. So,
Okay.
were there any questions?
Did you have a slide?
No, I took some pictures yesterday, just in case the rain is continuing and I wasn't able to share out in the yard.
Walk outside. Okay. Well, I did have a picture about our question on the fig tree. Are you going to
Oh, yeah.
in the winter?
Can you ask that again?
The fig tree, are you going to bring it in for the winter?
No, it's a hardy fig. It got a little bit of see if I can get back on. If I get closer, it got a little bit of winter damage just this past winter. But in general, they grow really fast and they're generally hardy. If you see some of the lower branches here that are a little longer, those survived the freeze. Some of these ones up top, they got nipped, but they're coming right back out again. So no problem at all. And I see I've actually got a little fig there coming.
Yay! Get that bird cloth
So-
over it, so you get to
Yeah, so
actually.
no
buy it.
trouble at all. I think a late freeze can nip some of the leaves back, but it recovers very quickly.
Comment from the audience is that he likes the cutting of the hoses as a drip feed.
Yeah, I experimented with a lot of things, and they all worked about the same. And what I'll do is come along, and if I notice some spot is not getting enough water, I'll just poke another hole or two there.
Okay, I think that was
There's
another question we had. If any of your plants were more thirsty than others. So it sounds like you just.
Yeah, the tomatoes in general like more consistent water. The ginger is a tropical plant. It likes to stay moist. I wish I could say I could kind of fine tune this, but the whole row gets all the water at the same amount of water for the whole row. So if there's anything that looks particularly neat, you can bring a watering can around and kind of top up.
Okay. Well, I think it's very interesting. I'd like to see a follow-up presentation as you get further in the season. Oh, well, I guess he just decided to get all the way off. Well, bye, Tim. Let's keep on moving with some paper now from Nate.
Hello, everybody. Can you hear me all right?
Certainly.
Great.
Oh.
So I didn't really get the memo on the theme of the 4 elements for this show and share. So I'm gonna be doing paper anyways. But this is a project I did at work, and it's a little silly, but I think it's pretty fun, and I had a good time doing it. So I'll introduce you to it.
And we
First,
all
slide,
have fun
please.
together, right?
Sorry.
We can all have fun together.
Oh yeah. Hopefully.
Just let me know if you need me to advance the slide.
Okay, could you?
Yes.
All right, so this is the Queen's corrugated chess set. So I came up with this towards the end of 2020, back when the show The Queen's Gambit had just come out, and there was, a huge rage for chess everywhere. And so things were pretty slow at work with the Christmas season kind of slowing things down. So I just took some time to have a little fun and try and make a complete corrugated chess, or a complete chess set out of corrugated paperboard. Yeah, it was fun. And if you go to the next slide, I'll show you what I used. Oh, maybe one back. Oh, I think we lost one. Anyways, the software I used for this was Artios CAD and Adobe Illustrator. Artios CAD is the CAD program that you used for making packaging material and like different kinds of packaging. And that was the main program that I used, but I also had to get some help in Adobe Illustrator for a couple things. And then this is the machine I used. It's a Kongsberg cutting table. It's about the size of a pickup truck, and it's made specifically for cutting paper. and it does a really good job at it. And now I'll take you through the steps of how I went about making this set. The next slide, please. All right, so my first step in most of these kinds of projects is to Google it. And I had a general idea of the process that I needed to go with for this. So I figured I'd start with the smallest part of the project that would determine the size of the rest of it, and that would be the chess pieces. So I went to Google and searched for chess piece silhouettes. And I was looking for something that didn't have a lot of contours or hard angles, because when using paper, it's easy to kind of tear these off a little bit, and it just makes it tougher for the machine to cut. So I was looking for something that didn't have a whole lot of knobby ends on it, like you can see with a lot of these.
Probably no.
Yeah, you gotta kind of consider that on the front end, and simplify it and dumb it down as best you can. And I'll show you what I went with on the next slide. So I was able to find a pretty simplified, silhouette of all the different chess pieces. They didn't have a lot of, knobby ends on them, and they all seem pretty easy to make and easy for the table to be able to cut. So what I did was I just saved that picture from Google, and then I brought it into Illustrator. And then I used the pen tool to roughly trace the outline of the different pieces. And you only have to do this once. So, and also it doesn't need to be that exact, because I was going to be cleaning up everything else in Artios CAD. So once I got those, the outlines made, I saved it down as a PDF, and then I imported it into Artios CAD. And then I'll show you what I did on the next slide. So then I, with my one copy of each of the different pieces, I had to, step and repeat everything out as needed. And I also had to make a tiny little slot, the thickness of the board I was going to be using, so that they could, the top and the bottom ends could nest into each other. So I rotated one out and then added the slot, and I grouped that selection, and then I brought the slot over to the next one so that it was right in the middle of both the pieces, so they both meet. There wouldn't be any, loose pieces of paper going around. And so I just made as many pieces as I needed, and went on to the next step, which was designing the chess piece carrier. So for this, I needed to consider the length and the width of the chess pieces, and I needed to step them out as needed, so they wouldn't overlap with each other or touch each other, and then they would just overall present well. And I also wanted to make sure it would square out, because I knew that two of these would be going in one chess set, and I needed that to be square. So here's a little insider look at how most boxes are made. So the three things that you need to consider are the length, width, and depth. So every box starts with that little variable input selection there. That's how pretty much all boxes begin. So if anyone ever wondered, that's how it goes. But yeah, once I had the box built and had the slots in, I was ready to move on to the actual chessboard, which I'll give an example of on the end. So this was made the same way as the chess piece boxes. I had to take the outside dimensions of whatever the boxes would be, the chess piece holders, and make sure it would fit them both, and it did. And also it would square up well, so it would, you know, look like a functional chessboard. And then I made a square, and then I stepped and repeated it across the top of the box, and I gave it a little bit of space between each of the cutouts so there wouldn't be, you know, loose material. And you could zoom in a little bit on that checkered section to kind of see the space left. And yeah, that's pretty much it.
Right,
And,
well,
so after this, I just, you know, set everything up to cut and send it to the table, and I had a corrugated chess set, and I think it should show it on the next slide.
oh, wow. So did you use different colors of cardboard to get the dark and light?
Yes, there's the brown board, that's standard. That's what we call in the industry craft paper. So there's no, like, it doesn't go through any additional process. And the white paper is referred to as mottled white, and that's given a white liner. And this was pretty special board because it was two-sided mottled white, which isn't very I don't know, common. So I was fortunate we had some in stock when I picked this project up.
Oh, I
But
hadn't thought about
the
that.
contrast turned out well, I thought.
Yeah. It's great.
Yeah, thank you. I think there's another slide that shows how everything fits together.
Oh, I see the slots now. Okay.
And then there's little holes on the sides where you can kind of pick the piece holders out.
Wow. Wow. This is great. So do you play often?
No, I'm no good. I really liked the show and I wanted to get better at it, but I kept getting beat by the online bots. They're really good. Makes it kind of discouraging to learn how, but be willing to learn.
Oh, I think that's great.
Thank you.
I bet John Dale's already trying to figure out how he could do that on his laser cutter.
Oh, it's not too hard. The pieces at least would transfer over really easy.
Yeah. Nice. I can't wait to see what you come up with next.
Me either.
Thank you so much, Nate.
I'm looking forward to it.
All right. And that brings us to announcements. So we've got a few things going on. We have a wood authorization class coming up this Saturday. Next Saturday, there is Wood Turning 101. That's Saturday the 15th. And a little bit of housekeeping for us, and literally housekeeping for us. Please clean up after yourself. Okay, Billy, I'll advance slides. Woodworking. Yeah, okay, so at 9 o'clock in the morning. And at noon next Saturday, or the following Saturday. And here we go, the housekeeping. Please take a little bit of time. If you see the trash is full, take it out. If, you know, for me, I've got a bunch of threads all over the floor, I sweep it up. Just kind of clean up after yourself. Make it enjoyable for the next member to come in as well as yourself. And of course, make sure the doors are locked, both the emergency door shut, lock, and the gate as you leave. Keep us safe. Keep us running. And then I don't see 5 people here, but I want to say high five. There's only 5 more weeks until Tuesdays, until we have our in-person show and share. Barring any craziness that may be happening. Oh yeah, I'm sorry. I get to talking and I forget about showing Billy in the front of the row. So they're excited to see Billy in person again, along with everybody else. But barring any crazy things happening, 5 Tuesdays. So once again, if you have something you'd like to share, just send the slides to show and share, SAS, at knoxmakers.org. And with that, I want to talk about donations. You can either use Smile, Amazon Smile, and a small portion of any of your Amazon purchases will come into Knox Makers, or you can donate directly. We've had some pretty good donations over the last couple of months. And I don't have the names on the tip of my tongue, and I don't want to get it wrong, but I want to thank you. If you're watching, I know you know who you are. Thank you for those direct donations. And with that, I think we can open it to an open chat. Something I dearly miss with the in person, but we do some video chatting here. And so I think we can stop the recording and get on with some chat.